Alright, in this video we're going to learn how to rationalize the denominator. When you're dealing with radical expressions, it's not considered to be standard form if you have a radical in the denominator, and I'm going to show you how to fix that. This is part 2 of the day 4 homework, and you should not be watching this video if you have not already done this assignment. So please make sure that turn this video off. If you haven't already attempted this assignment, do it on your own first. Do not copy off me. If you have no idea how to do the assignment, so that's why you haven't done it yet, still put your pencil down, watch me do a problem or two, and then turn off the video, pause the video, and go back and try to do the problems yourself at that point. But never do the problems as you're watching the video. You will not learn anything that way. Okay, now before we get started, let's make sure that you have a particular tool in your toolkit. Okay, I need you to understand that if I want to take the, let's say if I have the square root of 3 and I multiply it by the square root of 3. Alright, the square root of 3 times the square root of 3, what do you think that is? Yeah, that would be the square root of 9. But, oh look, that's a perfect square. What is the square root of 9? 3. Okay? Now I want you to begin to observe the pattern, and our goal is going to be to skip the middle step. So look, what's the square root of 5 times the square root of 5? Okay, now yes, that would be the square root of 25, but again, not a coincidence, we get a perfect square. And what is the square root of 25? 5. Okay, by now almost everybody is seeing the pattern, and you'll be able to skip the middle step and go straight to the 5. But let's do one more. If I have the square root of 7 times the square root of 7, alright, can anyone guess what the answer is right now without thinking about the middle step? Alright, let's see if you were right. But for the kids who are still catching on, 7 times 7 is 49. But oh look, perfect square. Square root of 49 is in fact 7. Now, the following will test whether or not you have learned the pattern that you need to learn. Because I'm going to give you a number that's too big for you to square in your head. Alright, so say if I had the square root of 147 times the square root of 147. Alright, I don't know what 147 is off the top of my head, but I know that the result of multiplying these two together will be, what is it? 147. If you knew that, then you have absorbed the pattern that you need to absorb. Okay, so if I do the square root of n times the square root of n, okay, then we know that the result is just going to be n. And I don't really have to put a question mark here. That would be n squared, and because this is a useful thing to observe also. The square root of n squared is going to be n. Alright, now we can get back to the lesson. So, rationalizing the denominator. Right now the denominator is irrational. It's got the square root in it. So we want to change this so that the denominator is a rational number, no more radical. But using the tool that we just practiced, I should be able to accomplish that by multiplying this radical by itself. Okay, so you can imagine what I'm going to get if I do radical 7 times radical 7. But first, it's important to understand that if we multiply the denominator by radical 7, we have to multiply the numerator by radical 7 as well. That way, we are really just multiplying by 1, since anything divided by itself is 1. Well, other than 0. Anyway, so what do we get? What's radical 7 times radical 7? Okay, 7. And in the numerator, we will just have negative 5 radical 7. So always look here to see if there's anything that we can reduce, any common factors. There are no common factors, so this is the answer for number 13. Please notice that we cannot do anything like this. Oh, the 7s cancel out. All right, this is, whoa, too much. This is just a 7. This is the square root of 7. You cannot divide a normal number with a number that's inside of a radical. So that's it for number 13. All right, number 14. Same thing. We can multiply this radical by itself, and that is going to make the square root go away. So if I do that, and let's make sure we do the numerator 2. Okay, so radical 15 times radical 15 is 15. And in the numerator, I have 3 radical 15. Now in this case, we can simplify these numbers, the 3 and the 15. Okay, just like we did back in the 3rd grade. Both of these are divisible by 3. Alright, and I'm hoping you can do this in your head, but this is what's really happening. 3 divided by 3 is 1, which we don't really need to show. 15 divided by 3 is 5. So in the denominator we will have 5, and we still have the radical 15. Okay, so basically we canceled this out. Alright, so that's the answer to number 14. Number 15. Alright, when you have the square root of a fraction, first thing, please understand that this is the same thing as the square root of 36 over the square root of 5. You can split it up into 2 radicals. Okay? Now, hopefully you recognize automatically this is a perfect square. The square root of 36 is just 6, so go ahead and do that. Now, what am I going to do next? Let's multiply this radical by itself. Alright, and we'll have to do the same thing in the numerator. Alright, radical 5 times radical 5 is 5. In the numerator we have 6 radical 5. There's nothing to reduce, so this is our final answer. Okay, that was number 15. Alright, once again, we can get rid of this radical by multiplying it by itself. We will have to do the same thing in the numerator. Okay, radical 3 times radical 3 is 3. Now in the numerator, be careful. Here we have the 2 radicals. We're going to multiply those together. So I'm going to have 15 and then radical 15. Okay, because 5 times 3. Now we can reduce the 15 over 3. Now again, technically we are dividing both of these by 3. That's what's really happening. But you know that 3 goes into 15 5 times. So we will just have 5. 3 divided by 3 is 1, and so we don't need to write a 1 down here. So we will just have 5 radical 15. So that will be the answer for number 16. Okay, number 17. Now be careful. In all of the previous problems, there was nothing to simplify under the radical. And what I mean by that is, like for example, if I have the square root of 20, I would simplify that by rewriting this. There's a perfect square factor of 20, and that's a 4. Hopefully you were just thinking that, because 20 is 4 times 5. You know what, let me just make it red. Okay, I made it red because it's special. It's a perfect square, so it's going to simplify and come outside of the radical. So what is the square root of 4? It's a 2. Okay, so we can go ahead and do that. Now the blue part is going to stay the way it is. 5 is not a perfect square, so it has to stay inside the radical. Alright, so this is how we simplify radicals. Now, hopefully you're recognizing that 27 has a perfect square factor. And I want to do that sort of off to the side. Okay, so, in fact, let me switch to my black screen. Okay, so I'm doing square root of 27 off to the side. So the square root of 27, what perfect square factor is inside of 27? 9. You know I still want it to be red. 9 is a perfect square factor. 9 times 3 is 27. Okay, so because 9 is a perfect square, I will take the square root of 9 and that will become outside of the radical. Okay, so square root of 9 is 3 outside of the radical. And then inside of the radical, we still have the 3. So the square root of 27 is 3 radical 3. Okay, so let's go ahead and rewrite. So this is the same thing as 9 over 3 radical 3. Now just compare that to the previous problems. A radical 3, there was no perfect square factor in there. Radical 5, no perfect square. Radical 15, no perfect square factor in there. Radical 7, nada. Okay, so the reason why we're suddenly doing something different is this is the first problem that had a perfect square factor on the inside, so we had to deal with that. Now if you wanted to, you could simplify this right now. I'm debating whether to do that right now or not. I suppose I will. You could simplify this right now. 3 goes into 9 3 times. So just to be clear, technically we are doing this. We are dividing by 3. We're dividing both of these by 3. Okay, 3 divided by 3 is 1. And because we still have this radical 3 next to it, we don't need the 1. So don't put it. 9 divided by 3 is 3. Okay, so far we have 3 radical 3. So now this is back to being like all the other problems. So what is my next move going to be, class? Yeah, I'm going to multiply the radical by itself to make the radical go away. Have to do the numerator 2, so I'm not changing the value. Radical 3 times radical 3 is 3. And in the numerator we have 3 radical 3. Well, look, we have to simplify again because these 3's are going to cancel each other out. And we will get radical 3. So this is your final answer. Alright, and that I do believe, yep, that was the last problem on this video. I hope it was helpful to you. I will see you on the next video.